Welcome, folks, to another module, and this one is going to be on managing the aircraft during VNAV operations, which really starts with the arrivals into most airports now, and certainly it applies also to approaches. But in this case here, what we're going to be doing is talking mainly about an arrival and some of the variables that you encounter during arrivals and the tools of what you need to monitor and use in order to fly the profiles and any kind of changes in these profiles. So with that, we're going to go ahead and get started here. And what I wanted to start with is for you to have an understanding of what are the most important tools to be using and monitoring and making adjustments. And by the way, what I'm going to do is something a little bit different. I'm going to give you this PowerPoint presentation. I'm going to do this whole series on VNAV operations in 3 to 4 different segments. This is going to be part 1. And with this PowerPoint, it'll be immediately followed with this presentation for a simulation on the portion that we cover here in these PowerPoints. But anyway, getting to the tools that you have in your arsenal here for VNAV, start here as always with the FMA. What's our present situation? Well, what we're doing is operating with the mode control panel in the following conditions. The autopilot is on. I can see that the autopilot is on. My PFD, we're at 20,000 feet, confirmed here, level there. We're in VNAV, so we're flying in VNAV for the course. But what we are presently doing is flying the mode control panel speed. And as we talked about VNAV mode, when we engage VNAV, what we're going to be doing is turning the vertical and speed profile over to the FMC, which we have set up here, and it's on the cruise page. So again, let's just review these tools that we have. So number one, we have the FMC, and that is going to be the source of information for how the airplane is going to operate in VNAV. And also, it's eventually what's going to happen here as we go to the descent page. It's going to tell us how we're performing on the profile and where we may have some deviations. So it's a source, but it's also something that needs to be monitored continually for performance. And I'll get into that a little bit later when we get on. But the mode control panel, that's for the operation of the aircraft and also the management that is going to be involved with speed intervention in the VNAV mode. So understand this, not only are we going to set parameters here, but we may have to adjust some of the parameters during the course of this arrival. And lastly, what we've got to monitor the performance is the PFD, the nav display, and the FMC when we get to some information on the descent page. So any adjustments that will have to be made will be operating on all 3 panels here. But now here's one thing I want you to understand, gang. When you're in the VNAV mode, and you're in any mode, when you're monitoring the PFD, at the same time monitor the nav display, which is right adjacent to it. Don't be in a habit of just using the PFD. This is all one instrument, because there's going to be so much important information on here that we're going to talk about that's available to you. It's going to be the top of descent here that we'll see here. We're going to start this profile descent, provided we are released to a lower altitude. So in any case, I want to cover some more of the details here, but essentially what we're starting with is we're at 20,000 feet, and the FMC is set up to know that it's 20,000 feet. And one of the ways that we notice that is that it's in magenta, and therefore when we engage VNAV, we're going to be able to go into the VNAV mode. Now, the other thing that you have on this cruise page at the present moment is telling you how many miles to the top of descent. And I can look on my nav display and see that's just about All right, at the 13 miles. So, all right, pressing on, what I want you to note is that we're in altitude hold. We're going to select VNAV, and what I'm looking to do here, gang, is to point out to you some of the present conditions that we have. VNAV is not engaged at this point. We're in altitude hold, which is the mode control panel configuration. Now, these areas on the PFD are going to tell us how our performance is, okay? And they're going to have a scale that'll come up over here on the nav display that we'll see once we start our descent. And we can see that we have a top of descent out here that is 13 miles away from us. So pressing on, what we're going to do is engage VNAV. And when we engage VNAV, the speed window is going to go blank. What we've done now is turn the autoflight director system over to the FMC. And in this case, what we've done when we've engaged it, because it had 22,000 feet to read, it turned the aircraft over on the mode control panel. We can see we turn it over to the speed that is in the mode control panel that's configured for cruise and then eventually descent. And we have VNAV path. Most important to have VNAV path in to automatically start the descent at the top of descent, our point right here. So we engage VNAV, and this is what we should be looking at to see that we verified we're ready for a VNAV descent profile. So you're going to confirm the VNAV path on your FMA and the FMC speed. Both of these need to be confirmed. This is part of the verbalize, verify, and monitor. And your airline may have specific procedures on how to do this, but I'll tell you what I would like to encourage. When I, as a flying pilot, selected VNAV, I say VNAV. And then what we're going to do is to confirm, indicating that it has engaged in those modes. And that ought to be continually verified by both pilots and monitored. Now, in order for the profile to work, as you approach the top of descent, you must be cleared to a lower altitude. So most arrivals will have a bottom altitude, and generally the clearance will be you're cleared to descend via such and such arrival. So you set the lower altitude in here because it's got to have a lower altitude in order to be released from the altitude that it's presently flying. So now this is ready to start a descent, and we have the lower altitude. And notice here, gang, what's already happened here with the speed. It's adjusted to the speed for the descent, 284 knots, and has started to slow here prior to the top of descent. So here's another most important point that I want to make, because from here on out, the flying pilot or one of the pilots ought to constantly be up on the descent page. If you depart it, go back to it, because this is where there's important information. So we're approaching the top of the descent. Go over to the descent page. Bring up the descent page, and notice it automatically goes over once you select it. But here's the important information that we're going to be looking for as we start our descent. Notice we have this flight path angle, vertical bearing, and vertical speed that is now does not have any information, but what it is ready to do is to provide some information. And we can see now we're 3 miles from the top of the descent. So now what we did is get to the top of the descent, and we're making this transition to the VNAV path profile. Notice that what's happened, we've changed a mode here because we've gone by the top of the descent. And now what this is going into, since we have the squares around the VNAV path and FMC indicating that we have transitioned into the descent profile, which is here on this page. Now, the other thing to notice is now we have information filled in. This is what is being programmed for the descent profile. Flossie at 4,000 feet or above. Notice what we did is fill in the flight path angle, the vertical bearing, and vertical speed. So with that, we have some important information that now has become available to us, and I want to constantly be looking at this page and looking at this information for knowing that you're staying on a profile, or if you're coming off a profile for any number of reasons, which we'll cover in future modules. I have a way to know how I have to manage the aircraft to get back to it. But I can see now here with what we've got, the vertical bearing. This is a computer information. This is the descent profile, vector profile of the aircraft in order to get to Flossie at 4,000 feet or above. That is an important piece of information to understand. That's the computer in the airplane programming this profile to arrive here. Now, what you're also got here in this transition that I talked in a previous slide about is that now on the nav display, we have a path indicator of how we're doing on that profile, as well as on the PFD, we have an indication too. These both of these are the same. And at the present time, it's telling us that the aircraft is not at the same vector descent profile as the computer is computing we need to be. Notice we are not quite on that profile. Therefore, during this transition, we're slightly high. And what it's doing is showing us that we're high on these indicators. So now what we've done is stabilize on the path just shortly after what we had seen, and we're still in the turn heading to Jafar. But notice now what's happened. The aircraft has automatically in VNAV got back to profile. Notice we see it here and here on the indicators. We are on the path. And this information is really important too now, because what I really need to monitor is that the flight path angle of the aircraft is essentially matching this vertical bearing, the computer, to the 4,000 feet. I see this information and this information are essentially the same to meet that profile. And I can go over here and I can see I'm not quite on that vertical speed profile because the flight path angle is a little bit different than vertical bearing. But you know, you're going to see some of those differences. Most of the time it matches up pretty good, but we're on the profile, and that's what's important. So notice here as we look at this, we're stabilized on this path and on speed as I look at the complete information that's available to me at this time. And these are what you need to be monitoring constantly when you are operating in VNAV on an arrival, and it certainly applies on an approach. All these indications are the things that you should be scanning and monitoring continually. Both pilots. We got too many things happening out there in the world, gang, where this information is not being monitored by both pilots. It's the only way that you're going to continue to work as a crew in a professional way to keep from having some of these crazy situations that are occurring out there right now. Now, part of why that's happening, I'm going to tell you in the best honesty I can, how to operate the auto flight director system and how to operate in VNAV is a very deficient knowledge base for an awful lot of pilots, such that you can't even monitor it in a way with any kind of knowledge about how the aircraft should be performing and how it is performing. I can't emphasize enough, gang, that this area is weak. Learn it, know it, get into your books. There's a lot of information, and hopefully some of these modules and information that I'm providing here, and I know there's others out there too. But hey, hopefully you're educating yourself on this. This is the most critical area of aircraft flying in approach and arrival scenarios. Okay, gang, God bless you all. Keep it up with taking care of your passengers, working efficiently for your airlines to save money. do a great job of passenger comfort as well. Safety number one, efficiency number two, or excuse me, passenger comfort number two, the priority of safety being the number one priority. Take care, gang, and as always, I'm going to wish you good flying. Keep the blue side up. All right, gang, here we go with the dynamic model that we're going to operate for the operation of VNAV in the early part of an arrival. Just to go over where we are at the present time, you can see we're at 20,000 feet. We have the same setup that we had with the power point. We're in the mode control panel mode. Notice we've got an airspeed in the speed window. We're at 20,000 feet. We have LNAV engaged and confirmed on the FMA. VNAV is not engaged. Therefore, the mode control panel is controlling speed and altitude. On the cruise page, we can see at the present time we're 13 miles from the top of descent on the nav display. Now, again, I want to really encourage you, gang, that whenever you're flying this aircraft, don't get locked in here as many people do. When you scan this, scan your nav display. And what it's going to do is force you to be more situationally aware to some of the information that is on the nav display. It'll help you scale it properly for the best definition. So with that, we're going to go ahead and release us here. And we are flying. So at this point, let's go ahead and assume that we got clearance to descend via the arrival, whatever that may be. And so with that, what we can do, let's go into VNAV, and we should expect to see VNAV. And VNAV path and FMC speed, because we did have on the cruise page is an altitude that it knows where it's going to be descending from. So, all right, so we've got FMC speed and VNAV path. And now what we're going to do is set the lowest altitude on this arrival, which is 4,000 feet. So I'm going to the altitude now, but I'm looking down here over my tape to set it. So we'll go ahead and set 4,000 feet. And what this is going to do is allow us, once we get to the top of descent, that it will start the descent. So here we are, we're 5 miles from this. Now what I'm going to do at this point is go over to the descent page, because we talked about this is going to be some valuable information for us to constantly monitor. So we're approaching the top of descent here, and what we have seen now is that it's gone into its descent mode. We notice that what happened is that it transitioned into the descent mode by the rectangular on FMC speed and VNAV path. We see we're in a descent, and we see that is now populated is the flight path angle and the vertical bearing. So we can see we're pretty much on path. It shows us a few feet high, but we can see on our nav display that we have our glide path indicator. And on our primary flight display, we also have that path indicator here. So what we have done is start our descent, and we're pretty much on path. We'll dress up our heading and monitor this descent. Now, again, to reiterate what is being calculated, this is a geometric path aircraft that's calculating through all the waypoints to this 4,000 or above at velocity. Now, with that, you can see that the power has come back to start the initial part of this descent. So we're in a very gradual descent, but it is on path. So with that, gang, this is the first part of this information that I wanted to share with you. But also what I really want you to be aware of is, I'm going to freeze this simulation right now, but what I want you to be aware of, gang, is that in an ATC environment, there can be any number of conditions that is going to create some changes that you might be directed to make. For instance, if they change our airspeed, if they tell us to maintain, let's say, 270 knots in the descent, or 300 knots in the descent. That's going to change the calculation of the path. Those are the things we're going to go over as we make some additional modules. The other thing that can happen is if they give us, let me go over to the legs page here, if they give us a restriction at a certain waypoint, for instance, if they have us cross the Piglet at, let's say, 14,000 feet, that is going to be, and we're going to go over this kind of thing. I'm not going to demonstrate it here, but I'm just giving you a heads up on some of the variables that can happen here. And anytime you change any information in the FMC and you're operating in VNAV and VNAV path, that changes the calculation, and that's going to change the parameters of the vertical, which means the flight path angle has to be managed to work back to it. And there's several different ways that you have to know how to operate to make that happen. We're going to cover those things. It's important because one of the things I'm really going to encourage you to do, if you're in VNAV, there's very few reasons to come out of VNAV in a descent profile. If you do, that's going to cause some subsequent problems for any later areas of where you're going to operate in VNAV. We'll cover those eventualities, those possibilities as well. But what I really want to encourage you to do is always do your best, unless it is some crazy, unusual circumstance, to stay in VNAV and manage the information to get back to path if you're off path. Because one of the things we're constantly going to be looking at here on the FMA, if the path is recalculated, this may go from VNAV path to VNAV speed, which means that is not on the parameters of what would give you a VNAV path indication. And we're going to talk about those details. So with that, I don't want to get any further into it and complicate it. We're just starting with a very vanilla situation here. We've started our descent, and it almost within a few seconds has gotten pretty much right on path. These two pieces of information, flight path angle and vertical bearing, can have some separation like it does now, but it's constantly going to be evolving. It's dynamic, and one of the things that we can see that's most important is we have no vertical deviation that the computer is sensing, and we can see right here on our indicators that we are on path. That's nothing but good. Okay, gang, that's it, and look forward to some further modules where we're going to get into some complexities so that you will know how to handle some of these things. This is an area that when you go through airline training, you don't really get much of this, and they expect you to learn it out there in the real world. And the evidence is over the years is that very few pilots, that includes veterans, know this autoflight director system with VNAV in a proficient way that they should. Okay, I don't mean to be critical. It's just the reality of what I've seen over the years of being an instructor and a check airman. All right, gang. Hey, as always, fly that little old lady from Pasadena the best way you can.